Hey, it's Sunday, July 28th, and check it out, man. We're in a little bit of a plan B here. After I got done finding those bearings that were, what was that, 7 millimeters wide, I thought that was the right thing with the 10 millimeter ID. I found these, which also have 10 millimeter IDs, but they're 8 millimeters wide and they're 22 millimeters in diameter. The ones I bought were like 17 millimeters in outside diameter. So anyway, I found these on Amazon for like 12 bucks for the pair. So I thought, well, let me get both of those two different bearings coming. And the first ones I ordered still haven't showed up. So I just went with this, and this is how it's going to go, man. So I made these two bushings. The inside diameter is approximately an inch, which is too small for the bearing to go in. But I got everything else right, except the flange. The flange is a little bit thicker than I want. And that's because I just used my cutoff, and that's not a real accurate cut. So rather than being short, I went a little bit on the heavy side, but they fit in the recess. And what I'm going to do, what I'm going to do is, let me zoom in here a little bit. I'm going to reduce the flange on this bushing, which is in there backwards right now, just a little bit, so that way I can stake the bushing like those stake marks that are there already. And that'll help to hold this thing in. It's an interference fit. We're about 3/1000ths of an inch tight interference fit, which that's really tight for that diameter. But what I'm going to do is double check everything. I already double checked this one here, that the length of this will not hit the bottom. It's short by about 5/1000ths. I'm going to double check this one. They're not exactly the same, but they're really close. And when I'm sure that they're all the same, I'm going to freeze these and heat up this thing and press these guys in there. Then we're going to be great. Then I'm going to chuck these back in the lathe, and I'm going to bore the ID of this to be the proper press fit for the bearing. And when the bearing is all the way to the back of the bore, it'll give me that 111 thousandths to the surface where the original bushings were. So everything is working out perfectly. Yeah, it's great. So it's almost midnight Sunday night here, and I've had enough for the day. So I'm going to leave those two sitting right there and call it a day. We're going to unplug and turn off the compressor, shut the valve, and there's the mess I made today, which I will clean up tomorrow or another day. Oh, we got to turn off my DRO. Here we go. Okay, we had the bushing in the freezer, and heated this guy up with the torch, maybe a little bit too much. Geez, looked like it started to melt down there. And this bushing just dropped right in the hole. That was about 3 to 4/1000ths interference fit. And there's number two. We're going to let these things cool off so I can hold them, and then we're going to stake these little areas so that bushing can't creep its way out of there. Next, we'll put this on the lathe and bore it out to fit the bearings. Well, that came out decent. I just used a pin punch in 4 places. 1, 2, 3, and 4. Same thing on this one. So those can't ride out, and that's fabulous. So now it's time to put this back in the lathe, and we're gonna grip it by this area once again and true it up because it doesn't sit in there straight. So we got to, run out and wobble, and then we'll bore this thing out to fit, and we'll put a chamfer on it right there. Perfect. All right, this is not the preferred way of doing this, to clamp it by the armature this way, but I've got no way of turning this true to that other than this. If I clamp the shaft on the other side, then I've got no way to steady this. I don't have a steady rest, and I don't have a way of, oh wait, I got those bearings. I could put this in a chuck and steady that end. This is good enough, I think. I've got this running true within a couple tenths, maybe 1/10,000th of an inch. And if I could do a skim cut on this, let's see how bad that's out of whack. I think it's pretty bad. All right, this is not the right tool for this. You're going as high as almost 5 there. Yeah, they're so I need to make myself a cutter for that. I don't think I'll be able to get away with a regular carbide tip, but I guess I could try giving it a skim with the standard carbide tip and see what it does. I think I've got to use high-speed steel made super sharp. All right, it's cut real nice now. I put some tap magic on it. And this is probably my last cut. It's a 1/1000th of an inch cut. I think I took off about 4 altogether. Oh yeah, gorgeous. Yeah, that looks great, man. So the reason why I chose to do this now, I got to clean out the grooves, okay, because you got some shorts in there. But the reason why I did this now is so I can make and then press the bushing onto the end of the shaft here, and then chuck it up like I have here and true up on this to cut the bushing OD. What I'm doing here is kind of scraping the sides and the bottom. This one's got a little particle down there at the bottom of it. Yep, just pushed it out. You see the crud down in there that I pushed out?
Is this the crust?
All right, man. I'd say that's about as perfect as that could get. So after I scraped the grooves out with a little tiny screwdriver and then the razor blade, I polished it with some 600 grit paper, and that looks great, man. So now, yeah, like I said, now that this is true, I can make the bushings to put on here and true this back up like I have it right now, and then cut this bushing OD to fit the bearing. All right, we are underway here making the bushing to go on the shaft of the armature so it'll fit that 10 millimeter bearing. We've got a little center drill action going on, and now we're going to drill. So what we've got here is this is the part that's going to go inside the bearing, and it's oversized right now. And we're going to put a flange on that 90 thousandths of an inch thick to replace the washers that used to be on the end of the armature right there by the commutator. And then this should give me exactly the right positioning of the commutator where the brushes ride. I got it. And it's almost exactly perfect, but it's within all my margins, so it's going to be great. I've got a 2 thousandths of an inch interference fit on the ID to the shaft, and the flange I was shooting for 90 thousandths. It came out on 80. Not quite sure how I goofed on that, but that's just going to bring the brushes a little bit further, 10 thousandths of an inch further onto the commutator, which I've got plenty of margin there. So now we're going to chuck this up in my vise and press this on the end of the shaft. Okay, take two. We are within 1 or 2 10 thousandths of an inch perfect, and it matches the commutator, which you would expect, but I was being extra careful here not to get something out of whack. So now everything is done here except the outside diameter of the bushing, which now we have to turn to fit the inside of the ball bearing with a light press fit. All right, man, we're on the home stretch. We're fully assembled on the bottom. I got it snugged up in the vise right now, holding on this thing down there. I got the bolts in. We need to make this bushing now, and I need to know how thick the flange needs to be to take the end play out of it. So right now, it's all the way down in that end play is where it needs to be in order for the brushes to be on the commutator in the right spot. So I need to get a measurement from here to here and then pull it up and measure it again, which is going to be kind of difficult because the magnet in here is kind of holding it down in there. Since I last made some video, I made some changes. I cleaned off the end of this. There was like a little pointy nub out here that I removed to expose the bearing more readily, so I could push the bearing out of the end bell for assembly or for disassembly, I guess I should say. So here you can see the original shaft, the brass bushing. You can see the ball bearing in there, And again, like I said, I cut this edge off here just to make it easier to work on. Okay, I'm getting 115 thousandths of an inch play. So that makes sense because we had 90 thousandths on the other side, and this motor had some end play in it, more than I thought we should have. So I'm gonna shoot for, guess I'll shoot for 115. And if it's too snug, I can sand down the flange of the bushing. So 115 on the flange. Well, those are some really crappy bearings. Interesting. There's a lot of play in them, man. They're just junk bearings. I can't believe it. Brand new. Didn't notice that until now. Hey man, it's Sunday, August 11th, and we're back at it again. We're going to replace our new ball bearings that we got from Amazon with something that at least looks like the real thing in a box anyway. Timkins. I already opened up one of those and they roll nice and smooth. So we're just going to swap those out and reassemble it. Okay, now let's see. Oh, much nicer. All right. We need to, these wires are not really heavy enough. They're getting a little warm. I need to hook this up to 12 volts and let it run for about an hour or so and let those brushes kind of wear in. Oh yeah.